Have you ever met someone who doesn't like a particular food, not because of the taste, but because of the texture? What if there was a way to quantify the texture of a given substance? Well, there is, and it uses a piece of equipment called a rheometer. But rheometers are expensive. They're very specialized pieces of equipment, but they can cost up to $200,000. I've created a version that's portable, easy to use, and costs less than $400. It's perfect for any classroom. We made it using a vernier sensor called a rotary motion sensor. Now, the one that we have here is connected to a LabQuest, but Vernier actually makes a wireless version of this that can hook directly into your computer or other device. We purchased the accessory kit that came with the sensor, and it came with these two discs right here. We've attached a third disc underneath out of a piece of spare aluminum, and that allowed us to have a nice flat surface to sandwich our sample. You can see our food sample right underneath there. I've used some red Jell-O, and I made it according to the box directions for Jell-O jigglers. This makes it a little bit of a stiffer texture. It won't fall apart when you try to cut it or pick it up in your hands, and it's really ideal for this kind of work. So I'm going to apply a small torque to that disc and allow it to oscillate back and forth. You can see it oscillating there. Now, if the sample wasn't there, the disc would just move in a circle, and the sensor would make measurements of angular displacement, velocity, and time. Because of the presence of the sample underneath the disc, we're going to get a damped oscillation, which is going to look like a sine curve, where the amplitude of the curve gets smaller every time. So I'm going to go ahead and press record on my sensor, and I'm going to give my disc a nudge. And you can see those oscillations back and forth being caused by the presence of that Jell-O. And when we look at the data, there we go, you can see that sine curve, and we can make measurements of the period of that oscillation and the difference in amplitude from one peak to the next, along with information about the geometry of the disc and the geometry of the sample. And that will allow us to calculate the stiffness of the Jell-O that's under there, something that we call G prime. If you have any questions about these calculations or about our rheometer, please feel free to contact us with the information below. Thanks for watching.